Ruchi, and today we are going to learn hybridization. So basically, at first I want to give a brief introduction about myself. I completed my BSc from Calcutta University, and after that I qualified IIT JAM. So after qualifying IIT JAM, I went to NIT Future for pursuing my MSc. From there, I was selected in IIT Hyderabad for the internship program. So during the coursework of my MSc, I have published 2 research papers that is published in foreign journal. And after that, I started my career with an academy. And after that, currently I am teaching in Narayana. So our today's topic is hybridization. This is the part of chemical bonding. So chemical bonding is a very important chapter in the perspective of NEET and JEE. Every year in question paper of NEET and JEE, we can at least see 2 questions from this chapter. So let's start today's topic. So basically, what is hybridization? Hybridization means mixing. All of us know. In chemistry, what is hybridization? In chemistry, we will talk about the mixture of orbitals. Okay, which kind of orbitals? Pure atomic orbitals. So, and another condition is there that the pure atomic orbitals should have similar energy. So, at first let's write the definition. It is the mixture of two pure atomic orbitals having similar energy to form new and hybrid orbitals. So basically here we are talking about the mixture of pure atomic orbitals which is having similar energy. Now what is this need of this hybridization? So to discuss that, we will take an example of methane molecule. So you can see this is the methane molecule. Here one carbon atom is there and 4 hydrogen atoms are there. Carbon is the central atom. So what is the atomic number of carbon? Atomic number of carbon is 6. So I can write the configuration 1s2, 2s2, 2p2. Okay. It is in the ground state. Okay. And which are the valence electrons? These are the valence electrons. So if I will write this in the excited state, then what will happen? Normally here this is present, right? But when it will be excited, then this electron will come here. Then what it will become? It will become S, 1s and 3p. Okay? 1s and 3p. Fine. Now hydrogen. Hydrogen is what? Every hydrogen is 1s1. Okay? So the electron is present in s orbital in the case of hydrogen. And in the case of carbon, you can see that 1 electron is present in S and the other 3 electrons are present in P. So here I can write S, here I can write P, here I can write P, and here also I can write P. So here which kind of overlap you can see here? Here you can see a SS overlap. Okay. Here you can see a SP overlap. Here also SP overlap and here also SP overlap. So in a same molecule, total 4 CH bonds are there. Among these 4 CH bonds, only 1 CH bond is SS overlap. But why the other CH bonds are SP overlap? Is this possible? In a same molecule, if the bond, if the overlapping of the orbitals are different, then how the bond properties will be similar? Then the bond properties will also be different, right? So in this way, a molecule can't be formed. So this is the wrong approach. Okay. So if we don't want to use this approach, we have to use hybridization here. Here what the problem basically? Here what is the problem? Here the problem is basically one is only SS overlap and the others are SP overlap here. But we don't want that. We want similar kind of overlap so that the bond properties will be similar. So if we want similar kind of overlap here, we need similar kind of orbitals at first. But here the orbitals are not similar kind of. This is s orbital and these three are p orbitals. So at first I have to create new hybrid orbitals which will include both the properties of s and p. For that, what we can do, let's see. Here the carbon, just I told you, it is sp3 in excited state. Okay. Now we will hybridize all of them. Hybridize means we will mix of all of them. Okay. So this is undergoing hybridization. This is undergoing hybridization. After hybridization, it will form same number of orbitals. Here, how many orbitals you can see? Tell me. 1s and 3p, right? So same number of orbitals it will form. That means after hybridization also it will form 4 atomic orbitals. Okay. But what is the difference now? See, at first it is 1s and 3p. Now all of those will mix together and it will form sp3. Okay. So it will form now together sp3. Now these all orbitals are named sp3 hybridized. sp3 hybridized. Okay. In every orbital, one electron is present. So now, if hydrogen will come, then also overlap will happen. Now the overlap will be more feasible. See, here 4 hydrogens are there, right? So now they will overlap. So now which kind of overlap we can see? Or in all the cases we can see sp3 and s kind of overlap. So bond properties will also be same. So this is basically the need of hybridization. Okay. Now we will discuss about different type of hybridization. Generally we can see 6 kind of hybridization. The first type is sp hybridization. Then sp2 hybridization. Then sp3 hybridization. Then sp3d hybridization. Then sp3d2. Then sp3d3. One question, that is, after up to sp3 fine. After sp3, why I am not writing sp4? Why I am going to sp3d? Because we know that p subshell has only 3 orbitals. Okay, so there is there is no probability of sp4. So after completion of these 3 orbitals, directly we have to go to d orbital. Okay, so d orbital will come into the picture and it will overlap with sp3. Okay, so now we will discuss about z. What is z? Z is the steric number. Okay, so why we calculate z? Basically, Z denotes the total number of atomic orbitals involved in the hybridization. Okay, so what is Z? What is steric number? Total number of orbitals involved in the hybridization. So here sp it is, right? In sp you can see how many orbitals are involved. 1s and 1p. So what? Steric number Z is 2 here. Very good. Now here. Okay, 1s and 2p orbitals are involved. So what is the steric number here? 3. Here 1s and 3p are involved. So the total steric number became 4. Here 1s, 3p and another d is involved. So obviously it will become 5. Here 1s, 3p and 2d orbitals are present. So that means here steric number is count total. If you will count, it will come 6. And the next one will obviously come 7 because 1s, 3p and 3d orbitals are there. Okay. Now what we will do with that? What is the need for us? Why we are discussing? We have to know their geometry. Okay. So let us discuss about the geometry. When z equals to 2, that means one central atom will be there and 2 side atoms will be there. Okay. Which example we can talk here? We can talk about BeCl2. We can talk about BeCl2. BE is the central atom and CN are the side atoms. Okay. So here the geometry you can see that is linear. Now total plane is 360 degree. In the total plane only I have to adjust 2 atoms. So what will be the bond angle? Divide 360 by 2. Come on. So what will be the answer? 180 degree. Okay. The next one. Okay. Next one I can take the example of BF3. Here what will be the geometry? Trigonal planar. Okay. Now think, in a 360 degree plane I am placing 3 atoms. Then what will be the side angle? 360 by 3, 120 degree. Now next one. Okay, 4 side atoms are present. Just now I told you about methane. So methane can be the best example here. Okay, methane, you can see that these 4 atoms are not in the same plane. Okay, so here the bond angle will become 109 degree 28 minutes. Here the geometry is tetrahedral. Okay. Now the next one, very important one. Okay, in the perspective of exams, this SP3D is a very important hybridization. Okay, so I need space for this. Okay, so SP3D, I can take the example of PCl5. PCl5. In this PCl5, phosphorus is the central atom, okay, and these 3 chlorine are the side atoms. But I told about PCl5, right? Then why at first I draw only PCl3? Because I want to tell you about the equatorial position and the axial positions, okay? These 3 chlorine atoms are in the same plane. That's why I have drawn it in the first. Now I will draw other 2 chlorine atoms. These 2 chlorine atoms are present in the axial positions. So here this 3 equatorial chlorine will form a planar structure. Okay, its name is trigonal bipyramidal. So these 3 chlorines are forming a trigonal kind of structure. And bipyramidal, why the name is called bipyramidal? Very interesting. Bipyramidal is what? Obviously pyramid kind of structure will be present. Now how this pyramid kind of structure is formed here? See this chlorine is forming a pyramid from the upper side and this chlorine is forming a pyramid from the down side. Okay, so that's why its name is trigonal bipyramidal. So at first I told you that these 3 chlorines are in same plane. So what will be the bond angle among them? Total plane is 360. Again divide 360 by 3. So I will get 120 degree for the equatorial chlorines. So here the bond angle will become 120 degree. And this chlorine is perpendicular to the plane. So here the bond angle will become 90 degree. So 2 types of bond angle we can see in sp3d hybridization. Next one, octahedral. Okay, now how to draw this? Suppose take the example of SF6. Here we don't means we have to keep these 4 fluorine atoms in the same plane, that means in equatorial position. Okay, and 2 fluorines will be in the axial positions. Now these 4 fluorine atoms is forming a plane, and again this is becoming like this. Okay, now why its name is octahedral? Okay, very important thing, why its name is octahedral? Because it is forming 8 phases. Can you see 8 phases? This one is one phase, this one is another phase, this one is another phase, and the back side one is another phase. Same it is happening in the case of the bottom fluorine atom. Okay, so here one phase, here one phase, this is another phase, this is another phase. Okay, so that's why its name is octahedral. Now can you tell me what will be the bond angle? Is same kind of bond angle is present in octahedral or different kind of? Just think and try to tell. Okay, I am telling for now. So here in a plane it is 360 degree. In 360 degree, total 4 fluorine atoms are there. Okay, so here what we have to do? We have to divide simply 360 by 4. Then I will get 90 degree. So here I will get 90 degree. degree. So here, for the case of octahedral, equatorial and axial atoms both are having same bond angle, that is 90 degree. Then the last one, that is suppose I can take the example of IF7. Okay, what to do IF7 is obviously 5 fluorines I will place in a plane, okay, equatorial position. This will form pentagonal like structure, and 2 fluorine atoms I will place like this. Okay, again this fluorine, this upper fluorine and the lower fluorine can form 2 pyramid kind of structure. So what will be its name? Its name will be pentagonal bipyramidal. Okay, so now we have to know the important formula to calculate the hybridization. Okay, if any compound will be given to you and they will ask you to calculate their hybridization. Okay, so how we will do? For that we have to use one formula. Let us see that. Okay, one thing I forgot to tell, that I am telling again, that is in PBP. Okay, in pentagonal bipyramidal, the last one we have drawn, its name is pentagonal bipyramidal. I did not mention the bond angle here. Can you tell? Obviously 5 fluorine atoms are there in a 360 degree plane. Divide 360 by 5, we will get 72 degree. Okay, so here the bond angle will become 72 degree, and here obviously it will become 90 degree. Understood? Its name I told you already, pentagonal bipyramidal. Pentagonal bipyramidal. Okay, so now let's come to the formula. Okay, so now what is the formula? That we are calculating Z state number. Okay, half into number of valence electron in the central atom plus number of monovalent atoms. If any positive charge is there, we will subtract it. Okay, if positive charge is there means we will subtract it, positive charge, and if any negative charge is there, we will add that. Okay, this is the total formula. Now discuss about some examples. Okay, 3 examples I will take and easily I will discuss. So at first I am taking NH3. Okay, just try to solve with the help of the formula NH3. So what is the number of valence electron in the central atom? At first choose the central atom, obviously nitrogen, right? So I know that 5 electrons are present in the valence shell of nitrogen. 5. How many monovalent atoms are there? Obviously 3. Hydrogen is monovalent, hydrogen's valence is 1. So half into 5 plus 3, I will get the answer 4. So just now I told you, if Z equals to 4, then what is the hybridization? sp3. Okay, sp3. Now the next one I will talk about, that is PCl6 minus. Half into, here in phosphorus, what is the valence electrons in the central atom? 5. How many monovalent atoms are there? 6. Now what I told, if negative charge is there, we have to add it. Okay? Then what it will come? 5 plus 6, 11 plus 1, 12 by 2, it will come 6. 6 steric number 6 means what? sp3d2. Octahedral. Then next one, PCl4 plus, if I will take. Okay? Again half into, in phosphorus, we know how many valence electrons are present? 5. Plus 4 monovalent atoms fluorine. Plus charge, see here, positive charge is there. Positive charge present means we will subtract it. That means 5 plus 4 minus 1. Okay? So it will become 4. 4 means again the hybridization will become sp3. So that's all for today. Thank you so much. Bye.